So I'm going to work on this Valhalla Scientific 2500 EP, and apparently it doesn't work properly. Well, that's the theory. So what this does is it converts a voltage into a current, supposedly. So you can input up to 2 volts maximum, DC to 5 kilohertz, works on AC as well, and it will output a current on these terminals here. And you can have a settled range. So remote control, so it's over here. If it switches in this position, it does remote. Or if you bring it around, it will come up to 10 amps maximum. I think that's like 12 amps max, but that's a 10 amp scale. So in theory, I should be able to put this on a small range and put this up to a multimeter and see what the current is actually going into the multimeter, if the ranging is working correctly. So if I put these onto, say, a 10 amp range in the multimeter, we should then be able to see if it's going to behave or not when we inject a voltage over here. That's the theory. It might go bang yet. So before I hook it up to anything, I'm just going to turn it on. It should be on standby, which is in this position. Turn the power on. Turn the power on here. Oh, check out that fan. It's like a jet engine starting up. I think that is changing. Okay, LEDs, see if they work. They do. Excellent. Overload isn't showing up. Now it is, maybe it's not, maybe it is, maybe it's not, maybe it is, maybe it's not. I guess this costs us nothing across the output. So it's cycling. Okay. Well, I've got to change that fan. Right, let's try this. Power it up. What I'm going to do is try powering from the PDVS2 Mini. I don't know if this can drive enough current or not. I think this can do 25 milliamps, I think that's what it can do. So I just want to try and provide this as a voltage source for this input, because it's very easily controllable. And then I'll just see if the current comes out changes when we're changing the voltage. So I'll turn it on. Output on. Put in 1 volt. Okay. Well, it's doing something. It's doing 7 amps. Even though I'm in the 100 microamp range. 1 amp or 1 milliamp there. 7 amps again. Okay. 10 milliamps. 7 amps again. You see a trend here? Which is why I wanted to start off in the amps range on the meter instead of milliamps range. Yep, it's doing exactly the same thing. EV1, 7 amps. Okay. So if I do remote, does that change anything? No, it's exactly the same as well. Right. A little smaller range, do 100 milliamps. Okay. We've got a difference here now. Now I'm doing 100 milliamps. Oh, sorry, 100 millivolts. We're getting a smaller current. But it's still way more than it should be. So yeah, something's definitely not right. So the 10 millivolts, we're getting a negative current. And it seems to have stayed there. Yeah, it's got an offset, negative offset there. So yeah, definitely not working correctly. I'm going to put it on standby. Yep, definitely not working correctly. So we've got some interesting symptoms there. It outputs the same current regardless of what range you're on. Very interesting. So when we looked at this previously, we had a positive power supply coming through and we're looking for a positive current. Because this is a push-pull system and it also handles AC, there's 2 banks of transistors. One is a positive reference, one's a negative reference transistor bank for the pass transistors, which generates the current. So if I invert the input voltage, do the same test again, we can check the other half of the transistors. All we've actually checked so far is half of the transistors. If we swap it around, we should be able to check the negative side and see if those are working. So we'll power this up. And we'll see if we get much difference. I'm going to put in 1 volt again. Now I need to put that onto DC. There we go. See that? We're getting negative 7 amps this time. So previously we got positive 7 amps. So therefore that fault is common to both the positive side and the negative side of the transistors. Exactly the same. Again, it doesn't matter what range you're on. There is some change there. There is some influence from that. It's not being completely ignored. So between 100 microamps, getting 8 amps, do 10 amps, you get 9 amps. So at 9.3. So yes, there's definitely something going on here. But it's common to both paths, a positive and negative supply, which means it's something most likely before that point. So I've slid the cover back just so you can have a look at it and let you see what it looks like inside. I'm going to slide this all back again and bring this forward once I turn it back on again. The brains of it are actually down here. This is where the actual conversation circuitry is and control circuitry is. It's right there. This is all the pass transistors. There's a fan mounted on the back of this heatsink here. These are two separate heatsinks. There's actually a very small gap in between them. There's not much of a gap, but there is a small gap between those heatsinks. And this side is the 2N6246s and this side is the 2N3055s. And so that's the push-pull arrangement. And as we saw, an equal amount of error, or roughly equal amount of error, I'm pretty sure the pass transistor side is actually okay. Something before that. So I'm going to actually slide this forward again, and we're going to ignore this section, and we're going to look at the front section here. And that's those two massive caps I was mentioning before, I think. 61,000 microfarad. So we need to check the voltages look okay. Main power supply rails first, to see if they look kind of right or not. Then we'll check the voltages on the op amp, which is IC4, which you won't be able to see me doing. Let's see what we get from that point. It has to be in operate mode in order to get the input voltage to pass through. We'll turn the PDVS2 Mini on. Set that to 100 millivolts because that seemed to do something before. Turn the power on. So in standby mode, the input's ignored. Let's stick this on a chassis point because I should be able to get any chassis point and measure voltages from that. So pin 4, maybe not that one. Maybe not. Here we go. Stick that over there. So I'll see minus 15 volts, which is looking pretty close there. And pin 7. Yep, slightly offset though. Probably doesn't matter. So those look alright. So let's check on the inputs, which are pin 2 and 3. I'm still going to keep it at 0 volt referenced. So this is with no input, don't forget. Nothing there. Nothing there. And the output is pin 6, I think. So we're getting negative 6 volts on the output. It could be that the offset is not set correctly on this. Anyway, we'll turn the input on. We'll measure that again. So pin 3. Pin 2. So those two aren't balanced. And pin 6 is still minus 6. And we're getting 800 milliamps current. What's that telling us? Not much, apart from the fact the input's not balanced, it would seem. IC3 is a different device type, it's a metal package. I'm slightly suspicious about IC4, the fact the inputs aren't the same voltages. The inputs should be the same voltage, they should basically be balanced out. So the fact there's an imbalance, that makes us suspicious about IC4 straight away. Let's pop that device out and see what we can get. So I've put in a TL081, which is similar to the OP07, except it doesn't have trimming. So it's got no trim capability on it, which may affect its accuracy, but for the time being it's just good for a pass-fail kind of test. Is the op amp good or not? And we'll just see if this changes anything. We'll try this again. We'll turn the output back off. Put that on. Let's enable the output. That's doing 1 amp. 100 millivolts. Okay, let's measure some voltages. So I'm on 100 millivolts again. Check pin 2. Put minus 6, I think is what we got before. 103, that's closer. There's on pin 3. Pin 6, exactly the same. So that op amp doesn't appear to be the actual issue. It's probably slightly different because of the trimming, where this op amp doesn't have trimming on it. So that's likely what's going on there. As you can hear, I've got it powered up. You can see all the relays energizing as I go through each one. So that is the 100 microamp range. That's 1 milliamp. That is 10 milliamps, 100 milliamps, 1 amp, 10 amps. Now you can see how far it is moving. See how much distance these are moving by. Look at the 10 amp one. Look how little that 10 amp one is moving. See that? It's barely moving. Is that a clue? Why? Yes, it is. Let's get really close. Can you see something wrong there? You see how much moving that one is? So that back one. Let's see how much this one here is moving by. And the 10 amp. Now look at the relay contacts. So if I look at the one behind it, might just be able to see them in there. So you can see those relay contacts opening and shutting. You can see both pairs of contacts, and you can see them opening and closing. But now look at the 10 amp relay. See those relay contacts opening and closing? No? That's because they're not. So this is the bottom of the circuit board. You just take the bottom cover off and get access to it easy. It's a really good design like that, it's really nice. This is the relay we need to take out. Loads of pins. It's a good job I've got a desoldering gun, so I need to use that to take all of these out, and then we can take the relay out and strip it down and try and fix it. So before I try and desolder this, I'm going to put some fresh solder on, because this is a relatively old unit, so I'll put some fresh solder on there. It will make it easier to desolder it. That makes sense? I've still got this massive tip on there, that's probably fine though. Might be helpful right now actually. It's got a bit of thermal mass in this area. So there's blue wire here which we need to move. Don't forget it goes to the top pin. You got that? Top pin, not the bottom pin, top pin. Right, let's desolder this thing. Right, let's see about moving these legs, see if they move. That's a no. Barely. This might take a few goes to get these off. Didn't do that one, did I? That's free. That's not. No. No. Yes. Yes. Kind of. Barely. Yes. 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 Nope. Nearly there. You're getting there. I'll come back once it's done. So I've got 3 pins I can't desolder, so what I've done is I put some solder back onto them. And now, because of where they are, it means that I can probably actually just wiggle this thing out and just heat them up and just gradually lift it out that way. That'll probably work. And let's go backwards and forwards between them. There we go, that's it. It's out. Let's clean these holes out. And hopefully there's any trace on the other side that's still there. There you go, there's the relay. R10E2Z4J2.5K. 8.4 milliamp DC. Can you see the contacts here? They're basically all shut together. It's all stuck. So they're probably pulling apart, see if we can get those apart. Thing is though, there's a lot of contacts to deal with. So it looks like I might be able to get this apart by shoving my tweezers up the side to push the sides out from the locking pins. And we'll see if we can then pull it out. I'm not sure it's going to work, but let's have a shot. Wasn't that easy. Okay, I've made some progress. I've got it started to move. I think we're just about ready to get it out. There we go. So now you can see those contacts here actually stuck together when they shouldn't be. So something's gone wrong here. See, that's the plate. See that move? See, when it's pulled fully out of the way, those contacts there are still shut. So what's going on here? I've moved the relay, so the 10 amp relay is now not installed. I believe there's an error on the diagram where it's showing a pair of contacts as normally shut instead of normally open. I think that's a drawing mistake because it doesn't seem to match the actual specs for the relay, unless there's a variation of relay which I can't identify from the data sheet, but it looks to me like it's wrong. So I'm going to test everything apart from the 10 amp range, and now that relay's not there, if it was causing a problem before by those contacts being shut, the other ranges should now work. That's the theory. So I'm going to inject voltages for this as I did before. I want to be on DC. Turn the power on. So no current so far on 0 volts, so 100 millivolts. There we go. So 100 microamps, operate mode, nothing there. 1 milliamp, nothing showing up there. 10 milliamps. I've got a really low voltage going right now. So it's not doing that massive current it's doing before. So 1 amp, okay, let's change voltages, let's do 1 volt in. Still got nothing there. Okay. So now we actually have no output whatsoever. Do 2 volts in, which is the maximum it's supposed to take. And we still have nothing at all coming out. So, we've changed it. We have proven it's something to do with that relay. So, it's no worse than it was. It's just different. So I think we got something right. Right, so I left that blue wire off that relay, which I think is actually the main 24 volt supply rail for all of the relays. So, I've put that back on again. That's pointed out by Ian Johnston, who's in my chat right now doing the live stream. Let's try this again. I've now reattached that wire. We'll put power on, put it in standby, power it up. Currently set at 0 volts input. Let's do 100 millivolts. Turn the output on. 1 microamps, nothing showing up, but it's not surprising because it's probably below what the meter can see. Let's do 1 milliamp, 10 milliamps. Oh, we've got something there. 100 milliamps. Yes, look at that. 1 amp. It's doing something. So let's go to 1 volt. There we go. It's doing something. That one's not right. So I think it should be basically like a 10 to 1 or 1 to 1 ratio. So okay, that's doing something. So 1 volt is doing 10 milliamps. So it's like full scale 1 volt. That's off. That's off. 10 amps should do nothing. Yeah. Okay. So it is kind of working. That one's got better now. Interesting. Now that's right. 1 amp is still down a bit. One of the switch needs cleaning. There you go, now it's perfect. If I do 2 volts, which is the maximum, put it on 10 milliamps so we can see it. Go to 2 volts, there we go, we're getting 20. So I can do 100% over range. So yeah, that's definitely doing something, and 10 amps will do nothing still. So yeah, okay. It looks like the other range is basically working, but we've got some issues. It could be adjustments because someone's been playing with it, or it could be issue with the switching or dirty relay contacts with the feedback. In fact, dirty relay contacts is actually quite likely. I might have to pull every single one of these relays out and strip them down and give them a clean. That'd be tedious, but it's working. And everything apart from the 10 amp range, which is the range I want it for. So with the 1 amp and 100 milliamp ranges not being consistent currents, each time I switched in and out, the current was different. It wasn't the same every time. It won't be the switch itself. I was thinking this can't be right because the switch is only controlling the relays. The actual current, there's no current or feedback going through the switch itself. It's all going through the relays, which means the 2 relays which are doing those 2 ranges, they both must need the contacts cleaning. If you work them enough, you might actually find they come right and clean themselves. You know, they have a natural abrasion anyway, but they are moving. There's a slight sideways movement across the contacts. like a slight cleaning movement. But if those ranges haven't been used much for a very long time, they will actually get a bit of oxidization on them and that will cause problems. When I did the Fluke 2450A, my resistance standard, that had issues as well with relays. I ended up stripping every single relay from that thing and cleaning every single contact. It took me hours, but it needed doing. This appears to only need it on 2 relays, at least so far. I might have to look at these other ranges more thoroughly to be sure they're okay. So I've got to take out those 2 relays, but unfortunately I've got to desolder them like I did the other one. I'm not going to record that process, I'll just pull them apart, clean them, put them back in again, and I think that'll fix those 2 ranges. I think that's always going to be wrong with those 2. So then that 10 amp range, I've just got to sort out a new relay for that. Then that just leaves me to try and fix this 10 amp relay, which is going to be interesting. So what I've decided to do, because at least these 2 relays here have definitely got dirty contacts, and these aren't easy to get out, so what I actually think I'm going to do is drill some holes in them, and I can spray some deoxit in. Rather than dismantling the relays out of the board, then stripping them down, we'll drill a couple of holes in, one each one. I should be able to again get spray of deoxit onto those contacts and then allow me to clean them with deoxit. It's not as good as doing a bit of abrasive cleaning with a bit of paper or something like that. It's not quite as precise as that. But if I just drill a little hole in, a bit of deoxit in there might be all it needs, just enough to get it working again properly. So I might just do that. In the worst case, it won't fix it and I have to take them out anyway. And I would have just wasted my time. But we'll give it a go. So I've got my Dremel here. Let's drill one right here. Okay. Do one here as well. Okay, so those drilled. Now I'll get some deoxit sprayed in there. Right, let's give it a go. Yep, it's kind of going everywhere. I'm hoping it'll go to like the top contacts and then drip down to the bottom ones. Putting way too much in there, but I need to get it onto all the contacts. And now I've got them in there. How much of it went inside them, I don't know. Quite a lot went outside as well. Now I need to energise these things and work them a little bit and see if it cleans them up. I hope it does. So I sprayed some deoxit in all these, did all that, operated the switches and stuff to try and work the relays a little bit. Now the 100 milliamp relay, that's working fine now, it's not playing up at all. The 1 amp is still giving me trouble. So I can go from 0 to 1 volt, it'll give me a certain voltage, might be a certain current output. Then I go up to say 3 volts, back down to 1 volt again, and the current output is now increased by 20 milliamps or something. But it's not consistent, it's not always the same. It may still be this relay is bad, even though I've given it a bit of a clean. Maybe that relay is bad. It's possible. So I think there's something else going on as well, not just that relay. Right, so I cleaned up that relay and actually cleaned up the contacts, stripped it down, got some paper in there and cleaned up the contacts, did all that sort of stuff, and bent all everything back to where it should be, so it's contacting properly both sides of the relay. So I think I've actually repaired that relay. At least maybe good enough. It's at least to do testing, it's good enough for that. And I've got to go through the ranges, so because it's such a low current, it's safe to switch the relays with it active, which is also what someone else has done in the past incorrectly and burnt that relay out. At 0.1, we don't see anything there. When you get to 10 milliamps, you should see 1 milliamp we do. 100 milliamps is working correctly now, as I said. That's working fine now. 1 amp should be doing 100 milliamps, and it's not. And 10 amps should be doing 1 amp, and it's not. And you'll see when I switch these backwards and forwards, the ratio is very similar. See, 830, 810, 820. Very similar ratios. Whereas that's just about perfect. So that one's right. If I do 1 volt instead, so it's doing 100 milliamps, that's absolutely fine. So this should do 1 amp, and it's doing 9. So there's something there, it's not linear. Maybe it's turns to the voltage going into the op amp. But yeah, so 100 milliamps and down is all working perfectly. Right, all those are working great. I'm happy with that now. But 1 amp and 10 amps, not so good. 10 amps is right up there. Anyway, so the relay is obviously working okay now. I've got that sorted out. But there's still something going on. I've noticed some interesting things going on here. So if I have no input, I've got to set to 0, got to set to standby, switch it on off, doesn't matter, right? So bring it round, 1 amp, do the same thing there, no difference, no problem. Go to 10 amp range, I've got an offset of 143 milliamps. In or out standby makes no difference. If you allow for the offset that we've got there, 144 plus that's 976. Very close to right. That's interesting. Now that's not the only thing I've noticed. Watch this. AC. 4.6 amps AC. I'm supplying it with DC. If I put on some DC voltage, the amps AC is also coming up. Put it on standby, it's still there. So even in standby, I've got 4.4 amps AC in that mode. Come to the 1 amp range, there is a little bit of AC though. It doesn't go to 0. There's AC coming through on the 10 amp range, and there shouldn't be. And the frequency is 21 kilohertz. Isn't that weird? Now I'm just probing the voltage on the output, 1.7 volts AC at 21.5 kilohertz. So I started reverse engineering some of this stuff because it's got various modifications to the circuit board, and I was trying to figure out, are they factory or not? Thinking they probably are, they do look factory, but I thought I'd double check, and sure enough I looked at the circuit diagram for one of the versions I've got. The modifications that are on this board match what's on that circuit diagram, so the circuit diagram I've got there is slightly later revision which has got these modifications on it. Now also mentioned over here, because I had some capacitors snapped to the back of the board here, I had this capacitor here which is a 2.2 nanofarad and a whatever this is, 502 mods, so it's a weird one. Anyway, that's across it as well, so these were in parallel together at this point right here, and that's factory, I believe. On the circuit diagram it's got 3.3 nanofarad as the value that's there. Well, that's a 2.2 there, and this other one here, that'd be a 5 nanofarad. Bit weird. Okay, so someone's maybe the factory changed it because it was resonating a little bit. Now this issue I had with the AC oscillating, things set to standby mode, and I'd be seeing an AC current if the thing was turned on, and that's messing up all the feedback and everything. So I think that's what's messing up the DC. So I took those capacitors out, I've changed it, I tried a few different values. I've currently got a 47 nanofarad installed. I tried 100 nanofarad as well, that worked really well. I've got a 47 in there, just a lot bigger than it was originally. I looked at a previous version of the board as well, a previous version of the circuit diagram, and this revision, this is part of the feedback circuit, so it's actually got a feedback circuit from the output, goes back into the output of the op-amp, kind of. It's like a little filter circuit. So that's obviously in there to prevent oscillation. So they've obviously added that in to address an issue with oscillation on it. Right, because that's the only time you do feedback, is if you're trying to stop oscillation. So I thought, okay, let's change these capacitors, let's put this one in. So now see what we get. Nothing. And if I do, that's on 1 amp range, do the 10 amp range, nothing sitting there. Okay, so if I do DC, nothing sitting there. If I try and do 1 amp DC on a 10 amp range, and I'll turn the output on, there we go, it's working. I'll bring this up, that should be 5 amps about there. Yep. So don't forget, these adjustments have been fiddled with. They're actually not adjusted correctly right now, they need recalibrating. Because I know the person that I bought this from said it couldn't be adjusted down, which means they've been playing with it. So anyway, so yes, I can go up to 10 amps. This ultimately won't like it or start flashing. But there we go, 10 amps. That is now working correctly, at least the 10 amp ranges. If I go down, put it back in standby, get down to the 1 amp range. If I try and do 1 amp, I'm not getting it. The problem with this is that it may have an issue with AC now, right? Because obviously it's an AC feedback path. This thing is supposed to run on AC as well as DC. So putting a different capacitor in here to kill the AC resonance that's in there might affect the AC performance. That's the only trade-off from that. I don't know yet how that's going to behave. It could be interesting. So there's a resonance with the original capacitors in there. That was about 21 kilohertz that's oscillating at. With a 10 nanofarad, it was oscillating at 17 kilohertz. So it lowered it down. So I'm thinking that the feedback loop now is okay. 47, it's like 4 times more. Is that going to be an issue? I don't know, because I basically put in double and it reduces by 4 kilohertz. So I'm hoping it doesn't affect the 5 kHz performance because it's supposed to go to 5 kHz. I'm going to have to test this on AC. So what I'm doing now is I'm just testing the frequency response. So I've got my oscilloscope set up to use the AWG, and that's outputting 100 millivolts RMS into this thing. So when I turn the output on, and this is on the 1 amp range, we're going to be getting a low reading because this one doesn't work correctly yet. I've got to calibrate it. But if I go up to the 10 amp range, turn it off, 10 amp range, we've got some residual noise here. If I do that, it goes away, I think. Yes. So if I turn it into standby mode, it goes away. It's probably just picking up some RF or something through the cable. Let's turn the output on. We're getting 1 amp. So that's at 1 kHz. So if I increase the frequency, and let's go 5 kHz. There we go. We're still getting basically 1 amp, but it's obviously dropped down by a little bit there. So the bandwidth limitation is there. We've got 4 kHz. It's better. Still being affected. There you go, 3 kHz. Yeah, so it's definitely being affected a bit by frequency. If I did say 100 Hz, there we go, 1 amp. So let's check the bottom end. Let's do 10 Hz. Yeah, that's fine. That's the limits of probably the multimeter itself. 25 Hz. There we go, it's stabilised quite nicely. So 25 Hz is fine. 1 kHz is fine. 2 kHz starts to drop off. If I say 997 at 2 kHz, in fact, let's do this more extreme. Shall we go back to 5 kHz? So we go 958 at 5 kHz. So now I'm going to try taking or changing this capacitor again and see if this value changes. Well, I've changed this now to a 100 nanofarad, which I know worked really well before, so last like the 47 did. Let's see if that's changed the frequency response. It's actually slightly better. Interesting. So let's go to 2 kHz. Yeah, that was 997 before, wasn't it? So 100 nanofarads actually looks like it's working better. Interesting. 1K. Yep, same as we got before. Let's change to 25 Hz. That's fine. So it's actually interesting that the larger value is actually looking like it's better. 10 kHz, which isn't what we're supposed to do. There you go, 915 at 10 kHz. Let's try this again. So I've now put in a 247 nanofarad, so that's quite a step up. And I'm doing 25 Hz, the bottom end's still fine. Let's do 1K. That's still fine, in fact it's actually increased very slightly. 2K, which we looked at before, that's increased slightly too. So this is affecting flatness, it seems. 3K, it's alright. Let's do 5K. That's come up slightly. It's actually relatively flat now. Let's do 10K. 932. So even 10 kHz is almost acceptable. This has got some good potential then. So I was worried about putting in too much capacitance. So I actually think this 100 nanofarad worked quite well. That might be the way to go. It did seem to settle it down quite a bit. 5 kHz, back down there. Yeah, okay. The 1 amp range has not been working reliably. Sometimes if I switch in and out of the range, it'll work perfectly. But most of the time, like 90% of the time, it doesn't work. Sometimes it will work okay, which means bad contacts on the relay. So I pulled this relay out as well. I've cleaned up the contacts on it. Basically do is get some deoxit, bit of gold G5 stuff, on a bit of paper, stick it between the contacts, hold the contacts closed if they're the normally open ones, and you just rub the paper between them and polish them up with that, try and clean up any residue. This has also got some signs of arcing just here, same as the 10 amp relay did as well. Then I'll put it back together now, and hopefully that will solve that problem. It worked for the 10 amp range, so I was able to get the 10 amp one working. That was far worse, so we should be good, I think. Right, I'm just retesting now to refitting that relay. We'll see if that's fixed. So I'm doing 100 millivolts input, 100 milliamp range, so I should be getting 10 milliamps. I am. 1 amp range, look at that, fixed. Excellent. Backwards, forwards, yep. Every time. Perfect. You can do this with low current, it's fine. When you do the high currents, it's when you get to being a bit pushing it with the relays and maybe causing problems. So let's do the 10 amp range, and that's reading. I need to recalibrate these, obviously, as I say, I've tweaked them a little bit, but it's still not there yet. Okay, so that should be good. So let's do 1 volt input. So we're going 10 milliamps on there, 1 milliamp on there, 100 milliamps there, 1 amp there. Exactly, bang on. That's fixed it. Clean the relay, did the job. Let's turn the current off. Turn this back on. 10 amps. Shit's fixed. I've still got to replace the fan yet, but it looks like I've basically got everything else sorted out. So I think I've basically finished this thing, but I'm not sure that I have actually, because I've noticed that the 100 microamp range isn't working correctly. I'm getting 99.6 and the adjustment for that range is not working. So something is going on there. And also the 1 milliamp range, the relay seems to be having problems with contacts. So I'm going to have to pull both those relays out, give them clean, put them back in again and see if that fixes the problem or not. Hopefully it does. I think aside from those two ranges it's basically okay. I do have an interesting situation though. I've noticed that the current draw on the main supply is like 250 watts or so with it idle. If I take the output connections off, even with it in standby mode, it will drop down to like 63 watts consumption instead. But if I have a load on here through a shunt, you know, it's like a multimeter hooked up, it's doing 200 odd watts. Or if I have it enabled. So if it's in standby it does about 250 odd watts or so, regardless of something connected or not. If it's an operating mode, if there's something connected, which is, you know, like a shunt through my multimeter, it's doing the same wattage. If I disconnect that, it's doing about 63 to 64 watts. I'm not sure why it'd be doing that. It doesn't seem right to me. If I've got no current flow through the load, where's all the power going? Like in standby mode, it puts a 1/4 watt resistor across the output terminals, just a 1/4 watt, and disables the input terminals. If I shunt across the input terminals as well, it does the same thing too actually. So I'm not quite sure what's going on. Why it's drawing that much power when it's not actually doing anything. That just doesn't seem right to me. I think there's something else maybe going on. Maybe once I fix these relays it will change something, I don't know, but yeah, it just seems like there's something else isn't quite right somewhere. I don't know why we're drawing that much power just sitting there, because in theory it shouldn't be doing anything once it's just sitting there. It should just be idling along and not really drawing much current, because it's not actually told to generate any current. So where's the power going? It has to be coming through these transistors and stuff like this. It must be going through there, but I don't know why. So I think I've got it all sorted out now. That error I was having with the inability to adjust the 100 microamp range, that trimmer, it was actually working. The problem was the relay was bad and it wasn't actually passing through the signal. So I've now actually removed every relay, cleaned every relay by hand and refitted them all. So I've done them all. Yeah, it's a shame, but anyway, I needed doing. And now it's behaving much better. Let's show you my Siglent multimeter up there. Right, let's try this thing out. Let's show you the actual readings again. So this is 100 microamp setting. Let's turn it on. There we go. Basically there. This is 1 milliamp. The O is 10 milliamps. 100 milliamps. A little bit of an error there. Might tweak the calibration a bit more on that one.
A few moments later.
Yeah, 200 milliamps, 100 milliamps. The 100 milliamps is fine. Right, it says the 1 amp range. Let's turn it on. Here we go, 1 amp. Let's do the 10 amp range. And it's 10 amps. There does seem to be a bit of a linearity thing going on here, so that's turning 10 amps there. If I come down to say 5 amps, it just looks slightly closer, I don't know. 2 amps? Maybe not, I don't know. We've got 999 there, go to 5 amps. 999 there. 7 amps. 999 there. 9 amps. Just drops a little bit there. So the very top end, it seems like it's got a little bit of a roll off on the top end, which is interesting. So yeah, I think that's basically fixed, short of me tinkering around with the calibrations and just getting it tuned and settled down. It seems to be basically behaving now. It seems very consistent on changing between ranges, that sort of stuff. We'll see how stable it is and how much it drifts around, that sort of stuff, but yeah, I think it's gonna be basically okay. It seems to be fixed, so don't forget to click like if you like the video. That's not right. Don't forget to give us a thumbs up if you like the video. Click subscribe if you're not subscribed yet. And I'll catch you in the next video. There's playlists at the end here. There's one here for things I think you should watch. Stuff there, YouTube things you should watch. Subscribe link over here. If you haven't done it, despite me nagging you. And there's a Patreon support link over there. Click on that if you want to support the channel. Help me to buy bits of test gear like this to do videos about. Catch you later.